Okay, so we now have the final example for our conical pendulum. Slightly different in that we have two strings attached to our particle. So we've got a particle C of mass 0.925 kilograms. I'm going to add that onto my diagram here. So that's at part C, and that is 0.925 G. I've got a horizontal circle of radius 0.24, so this particle here is rotating round. It's joined with these two strings that are anchored at A and B. Light and extensible string, so no elasticity, no mass or weight in either of those. They're both taut, so that means I've got a tension on each of them. So I've got my first tension and my second tension. And I can see here that O, A and B lie on the axis of rotation, so this is the point where it's rotating around, and I'm told these two distances here. I'm also want to just find that total, so my total height there from A to O, if I add those two together, is 0.45. I'm also told to take G as 9.8 metres per second. If we look at the angle of each as well, I'm going to say that this first angle for my T1 is alpha, and my second angle here for T2 for CB is beta. So before I start doing my horizontal and vertical, I'm actually going to look at the different elements of this that I might need to know for my equations. So I want to be able to know the length of each of these lines here, so C to B and A to C. So if I start with BC, my pen actually works, there we go. Again, for BC, I can just use Pythagoras. I've got 0.18, I've got 0.24, so it's going to be 0.24 squared plus 0.18 squared. Square root that whole section, so that's going to be 0.3 metres. And then if I do the same for AC as well, this time I've got my new 0.24, and you can see here this is where I needed my 0.45. So that's going to be 0.24 squared plus 0.45 squared, and that will equal 0.51 metres. Again, you can check these on your calculator, I'm just going through them quickly. I'll also need to know my sine alphas and sine betas and so on, so if I look at each of those in turn. So if I look at sine alpha, so I go to my diagram here, sine alpha is opposite over hypotenuse, and actually I've got those values now, so I could put in, I know that's 0.51 and that's 0.3. It might help me just to refer to that diagram. So my opposite is 0.45 and my hypotenuse 0.51, and so that is equal to 0.882. If I do cos alpha, I've got my adjacent over my hypotenuse, so my adjacent is 0.24, my hypotenuse 0.51, and that is 0.47. If I then look at my betas, so do the same thing with that, so sine beta, again I'm just looking at this smaller triangle here, so sine is my opposite over hypotenuse, so 0.18 over 0.3, which is 0.6, and then cos beta is 0.24, so it's my adjacent over my hypotenuse, again 0.3, which is 0.8. So that has set me up for doing the next part of this. So if you go into your blank screen, I'm just going to keep my other one nearby so I can refer to those values. So if I then look at vertically, now if you have your diagram by your side, I'm not sure you can quite see mine here, but if you have the diagram by your side, let's look at resolving vertically. So we would have T1 sine alpha plus T2 sine beta, and that is equal to our downwards force, which is 0.95G. Sorry, 925G. Let's put in the other values that I know. So my T1 sine alpha, I can put in the sine alpha, which is 0.882 T1. My sine beta, again refer to my diagram, my working out, so it's 0.6 T2. and then I can work this one out here, so that's 9.065, and there I've got my first equation. I can't do anything else with that, so I'm going to look at this one. You might start thinking, oh yeah, I wonder how I'm going to solve this. Let's do the same when we look horizontally. I'm just shifting that up, you get the idea of what we're doing. So horizontally, again, F equals MA. So if I look at my forces towards the centre of the circle, this time I've got T1 cos alpha and T2 cos beta. And that is equal to my mass times acceleration, so mr omega squared. I'm told, the reason I'm using this one is because I'm told in my question that the angular speed is 5. So let's put in the values that I know. Cos alpha 0.47, T1 0.8, T2, and that's equal to 0.925 times 0.24 for my radius times 5 squared. If I condense all of that little bit, so sort that out, I've got 0.47 T1 plus 0.8 T2 is equal to 5.55. And lo and behold, what do I have? So how would you solve these two equations? So two equations, two variables, you're going to solve them simultaneously. Now you can see I haven't got much space. I want you to stop and pause this video and try and work those out for me. I'm going to leave a little pause and then tell you what you're going to get. So while I'm pausing, I'll just write out that you're going to solve simultaneously. And you get T1 is 9.258 and T2 is 1.488. Now, if you have a look back to the question, you've actually told to use G as 9.8, so your answer has to be to the same level of accuracy. So we can't go and be given 3 decimal places because we were inputting a value that only had 1 decimal place or 2 significant figures it had. So we need to do the same for our answer. So we say T1, which is related to our line AC, is 9.3 newtons, and T2, which is related to BC, is 1.5 newtons. And there we are.